Okay, ladies and gentlemen, here's the third type where it's got an irreducible quadratic. Now, I've got a question here of that's a binomial. It doesn't have to be a binomial. It could be a trinomial, could look like a trinomial difficult or a trinomial easy. Doesn't matter. But this is an irreducible quadratic because it's not a difference of squares, because it's a sum. So here's how you set these up. Now, I don't care about the linear factors. You treat the linear factors just like type 1 and type 2. You could have non-repeating linear factors, and you could set up A over those, B over that one. If it was repeating, like if this was an x squared, for instance, you'd have A over x, B over x squared, and then you deal with the irreducible quadratic. So that part of it I'm not concerned about. But here's the new step. So we still set up our linear part, so A over x plus. Now I'm on to the next factor, which is an irreducible quadratic. And you set this up like this. Bx plus c over whatever that factor is. So now you can imagine type 4 would be a irreducible repeating quadratic, and so on and so forth, and you just keep going like that. It's so similar to type 1, 2, and 3 all mixed in. Type 4 and 5 just keep going. Okay, so this is what we've got. So when you got your irreducible quadratic, you set it up with this on top only when you got that. Okay, so let's go and multiply everything by our common denominator again. Nothing else changes, so x squared plus 4 cancels everything out. I get 2x squared minus x plus 4 is equal to a times x squared plus 4 plus bx plus c, which is a binomial, times x. Okay, so again, if you had repeating of these, or if a was a linear, a was over a linear term, and then b, a different term, was over another linear term, this would be a binomial times another linear. Like, it would get quite big and involved. Okay, so don't be surprised if some of them are a little bit uglier than others. So now we can go and simplify all this. Of course, this one isn't a very involved one on this part anyways. It gets involved a little bit later. Plus bx squared plus cx. Okay, so now we've got our, go and set up our term. Alright, so here I've already set up the coefficients. As you can see, I just took the 2 equal to a plus b, -1 equal to c, 4 equal to 4a. You can go and do all that, and then you just kind of problem solve here to solve for everything. Well, we've already got our c value. That's beautiful. Divide the 4 out of here. I get 1 is equal to a. Well, that's nice. And I can take that over and get b. So b would also equal to 1. So there's your three numbers. So now when I look back at the whole thing, though, you can see we got to go and plug that into this side here. So we're going to end up with an integral of 1 over x plus b is 1x and c is minus 1 over our irreducible quadratic, like so. So there it is. Now, this one's a pretty involved one, and maybe I'll do another video of one where it's not so involved, but I kind of chose this one on purpose because we haven't seen that type 6 from substitution where we did the inverse tan function. And this is a situation where it comes into play, okay? Because we're going to actually split this guy up. So this one gets split up, and we'll be able to use that whole rule, okay? Because even if we do substitution on this, it doesn't work. So we've got to do something else, okay? So on the first one, nice and easy, that's our ln rule. So it's the ln of x right there. But now when I split this guy up, I'm going to get plus the integral of x over x squared plus 4 minus, I'm just going to take the minus 1 technically out of there, over x squared plus 4. And you can see, because you have common denominator, it's still x minus 1 over x squared plus 4 if you break it down. So on this middle one, I can use substitution, right? U equals x squared plus 4. I get 2x. I divide the 2 out and all that stuff. So I'm going to take that next door here. We get the ln of x plus, when I do substitution on that middle term, letting it all equal and divide the 2 out, I get a half. And it's going to work out half ln of x squared plus 4. Again, I have total faith that you guys can do that substitution. But now I'm going to write this out again. Minus the integral of 1 over x squared plus 4. This is the one where when you look at this and you think of that inverse tan rule, it's very rare, but it's so helpful to know it, because I can't use substitution. I can't even do partial fraction on this, no matter how much I try on this. But I recognize that this squared plus something squared, hey, that's the inverse tan rule, and I'm just going to apply it without even thinking, as long as I know it. And remember, I gave you that hint of writing out some of these things on a piece of paper and having it always with you wherever you're doing your work, so you can just kind of look up and see the cheater rules and stuff like that. So when we come into that, remember the rule of that is 1 over a. So in that case, square root of 4 is 2. Inverse tan of x, the square root of x squared, x over a, like so, plus our constant. So without even thinking or having to think, we were able to do the integral using substitution for this guy, our cheater ln rule in that one, and then inverse tan rule in this guy. So, like I said, this one's a little bit involved. I mean, we used kind of everything we could possibly know in order to do this. They're not all like this. In fact, it's very rare that you'll get one of these ones, I believe. Maybe I'll do another video. I'll call it Type 3, Example 2.